Hey guys, Disaster Experiments here. So, bright field microscopy, which is the most common type of microscopy and the type that my microscope was, it can't be used to view bacteria because bacteria and light have an extremely close diffraction limit. This means that, bacteria, when it's in, a water environment and it's not dried out or stained, like you need to do to bright field to bacteria to view it under a bright field microscope. The contrast is not great enough that you can see bacteria on a water background. There are ways to increase contrast on a microscope. The most popular way, and potentially one of the better ways to do so, is to convert your microscope into a phase contrast microscope. Phase contrast microscopes have change phases in light into changes in brightness, which allows for a greater degree of visibility and against bacteria against the background. Could potentially buy a phase contrast conversion kit, which would convert my microscope into a phase contrast microscope. However, these kits are really expensive, and I don't have the money right now, so I would have to find a better way. I already managed to convert my bright field microscope into a polarized light microscope, which is for a couple bucks and a couple of broken 3D glasses and electronic screens. I managed to convert my bright field microscope into a polarized light microscope with much more contrast. However, there are a couple other ways that I could even increase the contrast further, like converting it into a dark field microscope. Convert my microscope, my polarized light dark field microscope. As you can see, I repainted it to match the head of the microscope. I didn't want to paint over the head because it's a Carl Zeiss model, and Carl Zeiss makes really good microscopes, and it looks cool. But anyway, to convert my polarized light microscope dark field into a traditional polarized light microscope, it's pretty simple. I just made these little filters by cutting out some plastic gum container and adding some Sharpie circles in the middle. However, what you do afterwards is you remove the condenser and you add some magnets, and you add this and you stick some magnets in there to hold it in. However, during my experimentation, I learned that I had a problem. I realized that by adding a blank one of these into here, and by realizing that the polarized light aspect of the microscope wasn't nearly as pronounced, that these little plastic slides were undoing the polarization effect of the microscope. A little bit of research, I realized that the majority of plastics can actually undo and mess up polarization techniques, meaning that I could not use these plastic filters that I built. Or at least if I wanted to have a hybridized dark field filter dark field polarized light dark field microscope. So I threw the plastic slides in the trash, and I had to rethink the idea. So what I did was I added magnets on the bottom of this, and then I made this. So as you can see, this right here is a glass does not mess with polarization in the same way that plastic does, or to the same degree, meaning that I could potentially use glass things. So this is glass with Sharpie painted on it, and I cut out different sizes of tape circles, and I did a bunch of experimentation to find the right sizes. And yeah, I also made some more magnetic slides. This way I can test out a large variety of different size holes, filter holes, and I can also create other sorts of filters like Weinberg filters for my microscope. So yeah, I successfully hybridized dark field, filter dark field, and polarized light dark field microscope. So hope you enjoyed, and see you in the next video. What I'm going to show you next is the fact that I have finally successfully viewed my bacteria that I grew in my petri dish under the microscope, which I never really thought I would succeed at. So this is the slide, as you can see, unstained. I used a plastic cover slip, but this plastic is so thin that it only slightly undoes the polarization effect, meaning that the plastic, for some reason this plastic is super thin and it only slightly undoes the polarization. Now I'm going to show you this under the microscope. So as you can see, there are a bunch of little dots, and these little dots are the bacteria at 650x magnification. Look at all they're not very high resolution, but I have finally succeeded in my goal of looking at bacteria under the microscope. They're not moving. However, they have been on the plate for a really long time, and I kind of suspect that they are all dead at this point. Or the species that I believe they are, Y. enterocoelitica, is non-motile at temperatures below 72 degrees Fahrenheit, and it's like 67 in this room, so they wouldn't be moving around anyway. So yeah, I finally succeeded in imaging bacteria with my microscope. Hope you enjoyed, and see you in the next video. I thought it could potentially be yeast, since I did use yeast peptone, cooked yeast, to make these cultures. However, I think it is somewhat unlikely that it is yeast, since first and foremost this has crystal violet, which usually kills yeast, and secondly, yeast does not necessarily... Yeast is usually a lot bigger under the microscope, or at least like twice the size as the dots that I was seeing. So I think it was bacteria that I was seeing, but I think that it's just a little distorted and blurry because, I don't know, the microscope's not like the highest quality. Objectives are kind of old, and it wasn't like the best microscope objectives to begin with. So anyway, hope you enjoyed, and see you in the next video where I improve the microscope further.